Hello, good evening everyone.
Good evening, Sir Ravi.
Yeah, good evening. Okay, then let's start. So today this is the week 2 assignment discussion for the solar photovoltaics principal technology and material course, which is being taken by Professor Ashish Garg from IIT Kanpur. And I am Ravi Kumar, a PhD research scholar at IIT Bombay under the PMRF scheme. So let's begin. So last time we were discussing about the radiation, how it reaches on the earth. So now let's see what types of radiation we have. Do you have any idea about the types of radiation we measure based on the measurement? Anything you know about these types of radiation? You can speak or you can type. It doesn't matter if you are wrong or right. We are here for learning. Anything monthly average global radiation. Okay. Same diffusion radiation. Yes. Yes, Malade, you are right. Actually, it is global radiation and diffusion radiation. Or diffuse radiation. We can say diffuse radiation. And one more type like beam radiation, direct beam radiation. Yes, we are not talking about this monthly, hourly or yearly. We are just talking about the types of radiation. So the last part of your answer is correct. That is global radiation and diffuse radiation. So let's see. We have global radiation and diffuse radiation, and one more we have direct beam radiation. Yes, actually beam radiation plus diffuse radiation is equal to global radiation. Here you can see this is the like one picture is showing here. The rays coming directly from sun are known as direct beam radiation, or they are coming after reflection or scattering. All those radiation is known as diffuse radiation. Diffuse radiation. So I think it is fine, you know, types of radiation. So do you know how we measure this radiation practically? If you are in the field and you want to know the value for the beam radiation and diffuse radiation today or global radiation today, so how can you measure that? Any idea? Any instrument you know? Okay, pyranometer is one. So this pyranometer measures which radiation, global, diffuse or direct? I request everyone, if you know anything about this, then you can write in the chat box or you can speak. Being an interactive class, we learn more. Yes, global, right. Right, Malade, you are right, it's global radiation. And for this direct radiation, direct beam radiation, do you know any kind of any instrument? Helimeter. Okay. Pyroheliometer, right. So you know much about this radiation and their measurement. You are correct. So let's see the picture of these radiations or like measurement. So first question based on this radiation and the measurement, we have choose the correct regarding the pyranometer and pyrheliometer. And these are the options. Pyranometer measures beam radiation, pyrheliometer measures global radiation, pyranometer measures global radiation, or pyrheliometer measures beam radiation. Which one is correct? A, B, C, D, or means there may be more than one correct answer. Okay, C, pyranometer for global radiation, and B, Rajiv Gyani is saying B, pyrheliometer. Malade saying D. So one person saying D, one person saying C and B. Anyone who want to go with A as well? See, we just now discussing pyranometer measures global radiation. So which one is correct from this? C. And pyrheliometer measures direct beam radiation. So from here we can see D. Yes. So C and D are the correct answer. C and D. Any confusion here? Rajiv, I hope this is clear now.
Yes, yes. Thank you.
Yeah. So have you seen this kind instrument in your life or any picture like pyranometer and pyrheliometer? Have you seen the picture of those instruments or have you used it in some experiment? Only peak in net. Okay. I just want to know if you have seen somewhere these instrument in the field or only on the internet or only in the books, and also do you have any idea how these instruments works? Nobody have seen this instrument? Yes, no? Only one person have seen, others haven't seen. Okay, so today is the day you can see today. So just look on your screen. You can see two instruments here. Now you will see I'm just naming it A and it's B. You just need to tell me which one is the pyranometer and which one is the pyrheliometer. Just look the structure and think about the kind of radiation measurement we need to do. Think about the diffuse radiation direction. Think about the beam radiation direction. Any idea? A is pyranometer. Very good. And B is pyrheliometer. You are right, Malade. Yes, it is pyranometer and it is pyrheliometer. So what happened? This is a glass here, and radiation is coming from all the direction. And see, let's assume sun is here. So beam radiation is also coming here, like this. So you can see these other radiation are diffuse radiation, while this one is beam radiation. So it is measuring global radiation. And if only beam radiation can go inside, only unidirectional ray, so this will measure beam radiation. Now, very interesting question. How can we find out the value for diffuse radiation? And this question is in two parts. If you have both the instrument, pyranometer, is B is rotating? No. Which one? This B. Yes, we can set it in the direction of sun. And even some automatic, yeah, I think you got the point. We can set it and there is a motor which track the sun. So here my question is, using both instruments, how can we get the value for diffuse radiation? Yes, east side to west side as sun position changes. Yes, this is like you can rotate it in this direction, you can keep up and down, and in this direction as well. So it is like a 360-degree movement. You need to get the diffuse radiation value using both the instrument and using only one instrument. So you just need to tell me, think a bit and let me know. If we need the value for diffuse radiation, then how can you get it? No idea? Should I explain to you? Or are you working? No idea. Okay. So first thing I told you, global radiation is equals to beam radiation plus diffuse radiation. So we are measuring global radiation, we are measuring beam radiation. So using the equation we can get diffuse radiation. One way is that, while using both the instrument. Second is, we need to block this beam radiation here and we will get the value of diffuse radiation. So what we can do, we can have something like this in the direction of sun. You can say a piece of metal which will block this beam radiation. And if this beam radiation is blocked, Then which radiation is left? Only diffuse radiation. So second method is pyranometer while blocking beam radiation. Any confusion you can ask. I can explain you again. Any confusion here? Okay. So let's move to the next part. Which is a question. It's kind of numerical. You need to solve it. So question says the monthly average of daily extraterrestrial radiation falling on a horizontal surface is 42,000. And ratio of monthly average of sunshine hours per day to monthly average maximum possible sunshine hour is 0.051. And if the empirical constant are A and B, the monthly average global radiation in kg or kJ per meter square per day, we need to get it. Just let me know, do you know the formula? Yes or no? If no, then I can give you formula. Okay, you know it. If you know, then work on it. For others, I can show the formula so that they also can work on it. You are saying A. Okay. He is saying A. I hope you use this formula only. So it is like 42,000 into 0.25 plus 0.45 into 0.51. So let me solve it. Okay, I can solve it. Oh yes, you are absolutely correct. It is 20,139 kilojoule per meter square per day. A is the correct answer. And I hope others also know the formula now. And I request you to work on this question. Question number 3. Same concept with different values. And these are the options. You need to calculate the monthly average daily global radiation. It is very simple. I don't know why you are taking so much time. Into 0.26 plus 0.43, 0.49. What is answer? I also need to calculate. Yes, same formula, different values. It is like hmm. In main exam we can use calculator. Frankly speaking, I don't know about the examinations, what are the instructions will be there, but I think a normal calculator will be allowed. So value for this is coming. Anyone have done this calculation? No. B 15650 kilojoule per meter square per day. Yes, you are right. B. B is the correct answer here. So now we are moving from this radiation part to the semiconductor part. So first part is, or first question is, how many types of material we have on the basis of electrical conductivity? Very simple question. How many types of radiation, oh sorry, I'm saying radiation again. How many types of material we have on the basis of electrical conductivity? Two, three. Can anyone name them? What are these? Metal, semiconductor, insulator. Technically you are correct, but there is a mistake. Mistake is that metal and semiconductor. Yes, you are right. But usually we say conductor, semiconductor and insulator. If you are saying metal, then where is non-metals? I am saying technically you are correct. No hard feelings, everything is fine. You are correct. Yes, conductor, semiconductor and insulator. So highest electrical resistance is with insulator and lowest is with conductor. So conductivity will be high here, or conductivity for the insulator will be low here. And these are the some examples. Gold, silver, copper, iron, aluminium are the metals. Silicon, germanium, selenium, gallium arsenide are the semiconductors. And glass, rubber, oil, plastic, diamond are insulators. Okay, I think this is in line. So on what basis this conductivity differs? Why materials are having different conductivity? Do you have any idea? Why glass, rubber, oil, plastic are not conducting electricity. Let's see, you have a piece of glass. Yes, you are saying conductivity is very small. Absolutely right. I am asking why. Why the conductivity is very small? What is the reason behind this? What is the basic unit? Yes, band gap. Now you are right. Large band gap. Band gap. Here we can see for the insulator, the band gap is the maximum or larger. While for this metals, band gap is almost zero. Conduction band and valence band are overlapping here. And semiconductor, there is a small band gap. So band gap, due to band gap, these materials are classified as insulators, semiconductor and conductors. So this is the picture we are seeing from our childhood. From class, I think 8th or 9th, we know this band gap, and I'm not sure, maybe from 10th class or 10th standard. So this picture is very well known. I am showing another picture to you for the band gaps, and you need to identify which correspond to which material. And this is the picture in front of you. Identify the type of material A, B, and 1, 2, and 3. This is the real band gap picture. You need to tell me which material is A, which material is 1, 2, and which material is 3. It is not that much confusing. Two is metal. Okay. He's saying 2 is metal. 3 is semiconductor. And 1 is metal. You did a mistake. Very minute mistake. Okay, Suraj Singh is back. Suraj saying insulator. But what is insulator, Suraj? 1, 2, or 3? 1 is insulator. He is saying not metal, it is insulator. And others 2 and 3, they are right. 2 is conductor. Means he is also saying metal, same thing. 3 semiconductor. Okay. See, for all these kind of identification, you need a baseline first. And in the y-axis, you can see we have values of energy, negative, then 0, then positive. So what should we draw? We should draw a reference line at 0. If we draw at 0, this is our reference line. And below this, it is valence band. And above this, it is conduction band. This is conduction band. This is valence band. But here we can see the line for conduction band is here. For this thing, this is the conduction band. Or for this is the conduction band. And for this, conduction band is overlapping with valence band. Now let me know. Do you want to change your answers? See, it is overlapping. There is some distance and there is large distance. So you are saying insulator. Yes, it is insulator. What about second and third? Third is metal. Yes, it is not semiconductor. It is metal. And second is semiconductor. Yes. Second is semiconductor. Third is metal. Now you are right. Great.
Actually, sir, one red line is drawn, na? ER.
Yeah.
Actually, I shown there is a continuity. That's why I tell you.
Yeah.
Continuity in graph. I haven't shown the conduction and balance band. I show the only graph. I saw this is continuity. That's why I tell the answer.
Yes. I got it.
Yes,
I got it. Why you were telling.
Yes.
Yeah.
Yes.
Okay, so let's move to the next part. Based on this band gap theory only, so just see these pictures carefully. Next question is based on that only. It says, do you understand the term direct band gap and indirect band gap? Suraj saying yes. Both are saying yes. So if you can speak, then speak. If you can write, just write very concisely. We don't have that feature so that you can draw and show us. I think that feature should be included. The band gap is called direct if the crystal momentum of electrons and holes is the same. The both conduction band and the valence band. Yes, absolutely right. Yes, why absorption is better? The answer lies in this Suraj's answer only, because momentum is conserved. So it will be fast, no change in momentum. I'll show you. I'll tell you in detail. So Suraj is saying, Gautam is saying absolutely right.
No, sir. Sir, actually, SAT's lecture, sir,
Sorry.
understand K value of maximum minima not coincide in indirect band gap. Okay,
Yeah.
sir. This concept I have understand, sir. This is big confusion, sir. Please explain.
Okay.
Yes, sir.
So you are like having confusion in identifying this minima maxima or what?
Yes, sir. Yes, sir.
Okay. So there is a picture on your screen. You can see if this is what? Minima or maxima? See, for this curve, this is just tell me if
Minimum.
minima, right? This is minima, and this one is
Maximum.
maxima, and here as well, this is
Minimum.
minima, and this is maxima. So what is it? If our electrons are here, just see at these positions, and they are absorbing energy, and they need to move upward because they will be getting some kind of energy. They will move to the upside. So like Suraj said, when the minima or maxima are on the same line or at same k value, we can say, or in the same line, we can say it is direct band. While these are not same in same line, like electron have to move this side. So what is changing here? Direction. And momentum is a vector quantity or scalar quantity?
Momentum, sir, vector.
Vector quantity. So it will depend
Value
on
and direction.
direction.
Sir, tell me.
Yes. So it is our indirect band gap. Here energy will change. What will change? Energy will change. What about momentum? And here energy and momentum.
Sir, he has to travel more path.
Yes.
This is the reason.
No.
For
This is not the more path. This is more like this electron have to move in the another direction.
okay,
Change in the direction happening here.
okay.
So here momentum will not change, while here momentum will change and energy will change. And you are asking this absorption why it is better in direct, because it is easy to move in the same direction or same line, or here we can say momentum is conserved, while here momentum is changing.
Okay, sir.
Yeah.
Yes, sir.
Okay.
Yes, sir.
Okay, so that's it about dark band and dark band. Let's move to the next part.
Sir.
It's very simple. Which of the following is true for an extrinsic semiconductor? Just note it. Extrinsic semiconductor. Here N denotes the electron, P denotes hole, and Ni is the intrinsic carrier concentration. And these are the options. And I know you know this question very well. A, B, C or D? C. Okay, may I ask which principle is it denoting? Which principle is it denoting? Energy, mass. Do you know anything?
Sir, can
I'm saying what is, why it is not less than or more than, why it is equal to Ni square. Yes. I'm not able to identify who is speaking. Actually, your voice is not clear much. Can you come again? Think about it. It is very simple. If we are like having any conductor and we are some donor or accepting, or we can say p type or n type impurity we are adding, then what will happen? Mass conservation, we can say it. Someone was speaking. Thermal equilibrium. Okay, just here also let me know what will happen with the intrinsic semiconductor concentration with temperature. Highly doped intrinsic semiconductor, I'm saying. Same electron and holes, yes. Yes, it is right. It is like that. We have a pair which completes them, like electron and hole. If we are creating, they will be created in pair only. Same electron hole in both bands. So based on that, we have this NP is equals to Ni square. Okay, we have this question. Temperature versus conductivity. You told me 3 types of material. Do you remember? Metal or conductor, semiconductor and insulator. So how they behave with different temperature? Just conductivity I'm asking. Proportional. See, leave it. Listen it again. I am saying conductivity of metal, semiconductor or insulator will increase or decrease with temperature. How they behave with temperature. Proportional, we know it may decrease or it may increase, but proportionality will be there. I am just asking, will they increase or will it decrease? Like we had what? Conductors, semiconductors, and third what was? Insulators. Okay, the conductivity. So now let's see one by one. Conductivity of conductor increases with temperature or decreases? It's okay if you know, it's okay if you don't know. Increase. Okay. Conductor increase. What about semiconductor? What about semiconductor and what about insulator? So question is, the conductivity of conductor, semiconductor and insulator will increase or decrease with temperature. Malade is saying conductor it will increase. What others say, I am waiting for them. You can write in the chat box. Increase in conductor. Okay. Suraj is also saying increase in conductor. What about semiconductor or insulator? Same. Okay. Now you will wonder. See, it is saying resistance. It will be opposite to conductivity. So for the conductivity, we can just do it like this. For conductor and for insulator, semiconductor. It is resistance and it is conductivity. I'll tell you the reason behind this. Why the conductivity of metals or conductor decreases with temperature, while on the other hand, conductivity of semiconductor increases with temperature. Now let's first discuss about semiconductor. So I hope you know this diagram for the probability function of Fermi level. You know it? Do you know this curve? Do you know the definition of Fermi level? Okay, you know, it's fine, it's good. May I know what is the temperature, or at what temperature this curve is like this? Zero Kelvin. But as temperature increases, what happens? We can see it like this. We can see this is our valence band, and this is our conduction band. So when conductivity is there, when charges or carrier like electron or holes are in conduction band. So at temperature increases, it changes like this. So you can see these charges are moving from valence band to conductance band. Conduction band. I'm saying conductance, it's conduction band. So these are moving with temperature. That's why we can say, or in other language we also know, we just say carrier concentration increases. Carrier concentration increases with temperature. And here you can see how it increases. That's why the conductivity of semiconductor increases. Now let's move to this conductor. Do you know why a conductor conducts the electricity? What is the phenomena behind it?
Due to free electron.
Yes, due to free electrons. So they are seas of free electron. You can say this is a conductor and these are the electrons. So what happens at high temperature? These electrons collide with each other at faster rate, which we say bombarding of electrons. And with increase in temperature, this bombarding of electron increases. We can say collision increases, and this collision increases, then the effective conductivity or effective movement of electron, like if this electron have moved to this place and it is like having multiple collision with other electrons, and this collision or these collisions are increasing with temperature more, so the time taken by this electron in reaching at this place will increase or decrease? It will increase. So effective movement of electrons inside a conductor will decrease or will be slowed down at high temperature. That's why the conductivity of conductor will decrease with temperature. I hope it is clear.
Yes, sir.
Okay. If you are understanding in one shot, then it's good for me as well. Okay, let's move to the next question. Oh, very interesting question. No options for you, and you just need to identify A, B, C, D. Let's see who will identify first. VB means valence band, CB means conduction band. Like this VB, valence band, or this CB, conduction band. So A is asking which semiconductor is this? A is P type. Wow. B is N type. A is P type. Okay. P type. B is N type. Yes, Suraj, you are also right. He is also saying A is P type. What about C and D? Yes, we know it's Fermi level, but it is known with another name as well, and different name for P and different name for N. You have said P type semiconductor A, that is absolutely correct. You have said B N type semiconductor, which is also right. Now we are here at C. Just think a bit more. EFP. What is this EFP? I'll tell you accepted level C. Okay. And D. Yes, C is acceptor level and D is donor level. For future, you can remember these things very simply. See, in P type we have number of electrons more. So let's see, these are the number of electrons. So for the conductivity, they need some level which will accept this electron, and that's why the nearby level is known as acceptor level. Right? D also said na, donor level. Yes, yes. And D is the donor level. Why it is happening? Anyone know? Why this Fermi level is moving up and down? Yes, due to doping. And due to doping, what happened? The distribution of charge carriers. Yes. Yes, it's correct, due to doping. Okay. So now you know the band gap for intrinsic semiconductor. Now you know the band gap for extrinsic semiconductor or doped semiconductor. What is the dark current in semiconductor? That we will come. Now we will see the conductivity. So here we have seen the extrinsic or intrinsic semiconductor. Now we have seen extrinsic semiconductor. Now we need to make it a PN junction. And the question you are asking is the dark current. Dark current is related to this PN junction only. So, do you have any idea how a PN junction's band gap look like? Do you know it? Any idea? Just think, on the screen you have p-type band gap, n-type band gap. You just need to connect them. Then what will happen? It's a bit tricky, but very simple. A slope. Yes, slope will be there, but why? Hello? There was some issue regarding this internet. Yes, you are saying a slope. Slope is the right answer. There will be slope, but how will we determine the slope, or on what basis we will come to this slope? Yes, yes. What is the common thing in both these two figures? P-type and N-type? You were saying like few minutes before, the same thing. The same thing. When I was asking about C and D, then you were saying some name. Fermi level. Yes. So for this, you need to draw a very simple diagram. Let's see. See, if we say this is P type, this is N type, here we have a level and here we have a level. Now we need to draw a PN junction for a band diagram for PN junction. So what we will draw first? We will draw Fermi level. Very close to CB and VB, right? First we will draw Fermi level. Then we are seeing here this Fermi level is close to this one, like we see valence band, conduction band, conduction band. So it is very close to here valence band. We can do like this. And for this n type, it is here. Just draw like this. So this is our p type, this is our n type. Fermi level will be same or at the same level, and now just you need to connect this, and this become a band gap for PN junction. Just have a look at this picture. Give me 2 minutes. Any confusion here? Let me know if you have any confusion here in this PN junction. Okay, let's move to the next question, which is very simple. Which of the following is your correct relation between the density of a state in 3 dimensions? And these are the options. Wow. C. Others? Not others, others. I think Malade is studying continuously or on regular basis. That's nice. Keep it up. Yes, option C is the right answer. We can see this is the formula for density of states, and here D is proportional to e to the power half. And definition of density state, you can see number of energy states per unit energy. Yes, C is the correct answer. Okay. A concept which is a basic one but very important while studying semiconductor, and that is drift versus diffusion. Anyone knows the difference between drift and diffusion? Okay, let me ask a simple questions. We are having deodorant in our room or in our home, and we are spraying that at a particular place in this room, we can say, and the particles which are coming out from this deodorant bottle, they are moving, they started moving. So what is there? That is drift or diffusion?
Diffusion, sir.
Diffusion. Now let's see another case. I am having a like same deodorant bottle and I am spraying in front of a fan. We have pedestal fan and I am spraying just in front of that fan. Then just let me know one thing before. The speed of spreading in the first case versus second case, which will be higher?
Sir, in second case will be higher.
Yes. So will it be drift or diffusion?
It is this, sir. It is basically
drift.
forced diffusion.
It will be both. In that case, it will be both. Drift plus diffusion, both. So I think you have an idea about this drift and diffusion. And in simple language, we can say, if there is a force behind any movement of a particle or charge carriers, then we can say that is drift. Or in other words, for the diffusion, we can say if a particle is moving or a charge carrier is moving due to difference in concentration, then that is known as diffusion.
Diffusion.
And you can see like a picture well represented. So here in the drift, we are having this potential difference. Due to this potential difference, these charges are moving. And here we can see these high concentration particles are started spreading, or these particles are moving. So this is known as diffusion. All clear here? Any doubts?
Yes.
Okay, sir.
Yes, fine. Okay. This question, it says, next question, the nature of variation of electron energy with wave number k for an electron in free space, and these are the options.
Parabolic.
Wow, so many answers. Malade, Suraj, great. Everyone is saying parabolic. So we just will see, this is the parabolic nature and this is based on this equation. Answer is C. So let's move to the next question. Question number 10. It says, in a direct band gap semiconductor. I know we have done this question before while we were discussing direct and indirect, but for the understanding purpose, we will see it again. So in an indirect band gap, an electronic transition between conduction and valence band results in, these are the options. But you should give me the answer here because I have discussed this.
D.
D. May I know who is speaking? Is it Suraj or someone else?
Sir Abdul Qayyum.
Abdul Qayyum. Okay, great. So this is change in both energy and momentum. D. Okay, so this one is the first part of these assignment solution, and second class will be tomorrow, and then one class will be on Monday. And also,
Okay.
if you have missed first class, you can go on the YouTube. I'm just pasting the link. This is the channel for this NPTEL course. You can click on this link and you can see the first lecture as well. And
Okay, sir. Thank you, sir.
in the first lecture as well as in the second lecture or the coming lectures, if you have any confusion while we are not having an interactive class, or while you are watching later at home, so what you can do, you can comment there. If you have any kind of doubt, I'll reply there only. Is it fine?
Okay, sir.
Yes.
Thank you, sir.
Okay, thanks a lot. Have a nice day. And be interactive. I want you to be interactive. Interact as much as you can. Thank you, everyone.
Okay, sir.
Yes.
Okay, sir. Sir,
Yes.
tomorrow
Sir Ravi.
again your class, sir. Tomorrow.
No. My class will be on every Friday only.
Oh, only every Friday. Okay.
Yes.
Okay, sir. Actually, I have some doubts, sir.
Okay.
Actually, some assignment questions I get wrong.
Okay.
Okay, then just now result come na. Some these wrong questions, some questions I have doubt.
Okay.
Just
So
one, two.
which assignment you are talking about?
Main assignment.
Assignment
Suppose
2,
one,
1, 3, which one?
assignment two.
Okay.
Already result out. Okay, sir. So I have seen some. I have made mistakes.
Okay.
Okay. That I made mistake that this I don't know. That's why I made mistake. So some part I want to know, sir. That's why I'm unable to answer assignment two. One, two questions, sir. If you have time.
Yes, we can. It's fine. You just let me know the question number.
Okay, sir. Okay, sir. Sir, assignment two, question number 5.
Let me write. Assignment 2,
Question number 5, 6.
5, 6.
6.
Okay.
And sir, question number 12.
Question number 12.
12.
Okay, 5, 6 and 12.
Yes, sir.
Right?
Yes, sir.
Okay.
And sir, one thing, 15.
15.
Yes, sir.
Okay. Okay, then see. Hello.
Yes, sir.
Yes, actually we are having a team. So tomorrow the person who will take this tutorial, he will solve all these questions. I think he will solve first 2 questions tomorrow, and this 12 and 15 will be solved on Monday.
Sir.
Even if you want, I can include all these questions in my next presentation as well.
Okay, sir. You include no issue, sir. Just already the question answer sheet comes, no issue. Just I want to discuss. So next class you add, sir, please.
Yeah, next class we can discuss. I will add it.
Okay, sir.
All the
Doesn't
4.
matter, sir.
Yeah,
Yes.
all the 4 I'll have in my PPT. Don't worry.
Okay. Thank you, sir.
Yeah. So someone is joined very late. So this is the link for this YouTube. You can go on this YouTube channel and you can watch this lecture and even the before your previous lecture as well. So others, they are also having any kind of doubt, or they want to discuss some thing in the next class, they'll just let me know. I'll have the things in my PPT, then we can discuss whatever you wish for, any concept which you are not getting through lectures, anything, any questions.
Okay, sir. I believe, sir. My
Yeah, if you have
office.
done, you can leave this class, it's fine. I'll include your questions, don't worry.
Okay. Thank you.
Yes. If you don't have any doubt, then I'm going to end this class, and we will meet next Friday at 6 p.m. And if still you have any doubt, you can write in the chat box, or you can ask directly. Previous year paper, Kinjal Pandey. So which paper means? Entire paper, like this main exam paper? See, if you are solving these assignments, main exam paper of our course, I need to check, because I don't have any idea about this exam paper and all. I'm just here for discussing your doubts and your assignments, but I'll look into it. If I get the paper of the like previous year, I definitely will provide you. Okay, thanks everyone.
Thank you.
No, I did. Kinjal, you just go here and just check and let me know. I uploaded in the 15 minutes only, like by the 7:45. You just check once, and in the playlist you will see playlist for this photovoltaic course, and there will you find a video.